So this presentation, it's a bit of a meta presentation. So if you still want to leave, that's fine. The first step that we're going to do is kind of describe the models or the diagrams people have used in the past to explain DevOps. Then we'll go to seeing the system, kind of understanding where this is valuable in the wild. And I'm going to introduce a practical technique which I dubbed monitoring stream mapping technique, and some observations when I run it at customers. And then the next part is focusing on the flow. Once you see the system, finding areas where you can do improvements and relate that back to some example practices that people do. So if you still want to leave the room, that's fine. It's your opportunity now. The models that people use to explain DevOps. I think this is the most simple one. And even that people are able to screw up. There's something in the middle. So whatever you tweet about DevOps, it's not something you do on the left or right. It has to be something related to somewhere in the intersection. So even that. Most people kind of see it as the extension of Agile. Michael has kind of described it. You know, continuous delivery, DevOps take it to the next steps of deploy and operations. And this is what I call the myopic DevOps view. It's somewhere in Dev and Ops, and there's a tool in the middle, and people kind of go from there from one side to the other. Which I hope in this explanation or in this session that I can kind of open your eyes that it's not just on these tools, although that might help. Who has seen this diagram before on DevOps? Only a few? Okay, that's interesting. What this diagram clearly adds is that there's dollars at the end. So we're doing this somewhere for the business. It's also referred to the aha to ka-ching moment. It's somewhere in the middle that this wall of confusion is, and we're trying to shorten the time between having the ID, getting money for it. So yeah, simple diagram, but it has some value. When I coined the term, there was like no strategy or anything with it. I was just like doing Agile stuff and things happening. People have almost brought DevOps to the religion level sometimes, which I don't think it is. It's just a set of practices that is emerging. And the diagram really shows that we're borrowing from the lean principles, and that especially between Agile development operations, new practices, people started to exploit that or kind of trying to do. And that's kind of where the blurry line of DevOps lies. So it's a set of practices borrowing into principles from Lean. The most prevalent model now that people refer to when they explain DevOps is the very simple thing. Before you do anything, you see the system that is actually happening between Dev and Ops. So not your own silo, but understanding the whole picture makes it useful for you to like do an optimization, maybe take a shortcut in development, and then it has like a huge effect on operations. So seeing that, being aware of whatever you do in the development environment, that it can have an impact, or saying no in the operational can have a huge impact in development. That's kind of understanding whatever you do in one of those silos that getting that clear view is important. Once you get that view, you will focus on the flow of getting things moving. We'll go into that. It's basically eliminating any friction to go actually faster to production. And then once you start doing, it's going to be things changing in your organization while you're kind of doing new practices and trying out new things to remove your bottlenecks. And you'll have those feedback loops. They might, like a feedback loop can be positive and it can be negative, so be aware when you're changing things, some things might totally go the wrong way. Be aware of that, seeing that in your system is important, but also understanding that you might optimize something completely, you know, let's do the minimum disk size, we can do this stuff, and then all the other feedbacks go like, whoop, whoop, and it totally goes wrong. So seeing that, and then continuously improving. It's a very simple way of thinking over DevOps, but you kind of get the idea, continuous improvement, understanding your system. So first part, seeing the system. How many people have heard of value stream mapping before? Okay, few. Who has done it before? Kind of the same people, so that's good. I'm not really going to explain much about it, besides it being a visualization of you getting towards production and understand all the steps you have to do. What I'm going to describe here is monitoring stream mapping, and I tend to think of it as a reverse value stream mapping. So we go from production back to actually the value. The reason why I do that is because I often end up in operational groups where the term monitoring kind of gets them excited, but it's not about monitoring anyway. But they kind of think it's about Nagios and all this cool stuff that they want to do. So you'll see that the term monitoring is kind of as a side effect to get them excited about this. So when I go into a company, I get all the different silo groups in one room. So basically, everybody has their view on the system. And then I, just like value stream mapping, I take a big wall where people can put Post-its on it, and preferred it's going to be in their daily workspace, so not in the actual meeting room, because the way I think of it, it needs to be a live kind of ever-changing model that they have on the wall. So clearly, if it's in a meeting space, other people will rip it apart, remove it, or start drawing funny things on it. So let's try to avoid that. And then just a bunch of Post-its with some different colors. You draw 4 quadrants, and I start in the production upper right corner. And a simple question, put all the production components on the board. Easy, 1 component, 1 sticky. The reason why I don't do it on a whiteboard is because on a whiteboard, once you've used the marker, it's pretty hard to kind of redraw everything. A Post-it, you can just move it around, makes it very easy. You'll be surprised just by asking that question, how different people will come up with different product components. Oh, there is a payment gateway here somewhere, and there is a fax system that we need to do here. And it's just because you get all the people in the room, you get a more complete picture of what you're doing in production. It's actually your architecture or your systems architecture you're trying to put on the board, so it's more on the technical side. And this is the best. Obviously, if people say, I don't know, especially if you never used to production, it's starting the conversation. It's merely that. If you never know what's out there, how can you even keep like what you are doing relating to the impact you will get on the other system? You might just rely on the grumpy admin saying to you like, no, this is wrong, or you shouldn't do it. But if you can anticipate that, it just removes a lot of frustration. Next part is, I ask them what's production. And for some reason, a lot of people forget their external dependencies. Like the cloud, everything they do in the cloud, they kind of don't assume that it's kind of production because it's somebody else's problem. So map that on the board as well. It could be your Gmail because all your tickets get mailed there as well. It could be any ticketing system, EC2, S3, just name it, put it on the board as well. Again, it's seeing what's out there. Maybe within the application, the developer does a strange call to an API to a product somewhere. All these parts, put them on the board. And then, especially in the enterprises, there's the internal dependencies. There's the firewall, the network, all that things that you're making abstraction while making the simple drawing of web app DB that are out there as well. So if they fail, nobody gets the aha to ka-ching because there's clearly no connection with the user, so it's dead. And then there's the supportive. It always amazes me that they have these crazy production line setups, and then when you ask them, can we look at your monitoring system? It's just like one guy somewhere in the corner setting it up. It's not really production. I say, well, If it's not running, how do you know it's running? So there's this tendency of not putting those parts as production, which they are, but it's important that you, apparently that you specifically ask your backup, your logging system, put them on the board, because if they fail, you might not get a notification, so it's very important. So, and then you continue the conversation. How does it work together? You know, you work network flow, components talking together. Now that we got all the components, you start a conversation. How do you know that these components are working? And this is the part where kind of let you get the monitoring. They go like, oh, we have this awesome check that logs into the machine and gathers whether the service is up and so on. I don't really care that much because I care about this. It's making the mapping between whatever they're monitoring in production. I ask them, put the core functionalities you provide to users. And this is where I get these kind of question marks on people's head. What we actually don't know. We've never used the system. It's funny, but we can't log in because it requires for a credit card sign-up. So it's important that they see it's just like BDD, kind of the outside, the functionality you're providing is look what functionality with the components that you're providing. And the nice thing is, if you can't find an end user kind of functionality that crosses your components, you might have missed something crucial. So it gives you this mapping of functionality components. It will also give you the intersection of many functionalities crossing one component as, hey, this might be an important one that is used by many systems, like the logging system might be an important, because if my users can't log in, then obviously a lot of these functionalities don't apply. So components architecture. And again, it's an exercise I do with people. So I ask them to repeat the same process, but now not for components, but for people. Tell me the people that are involved for production. Where's your support group? Who are you going to call? All that. All the external people. You might have third parties. So you see the pattern here. There's components, there's the people, and you just keep going. Maybe there's someone supportive. Who are you going to call if your disk on Amazon crashes? Oh, shit, I have to have a support contract. Oh, yeah, let's do that. Again, how they interact, that's basically mapping your process. And if you have your components, your architecture, and your process, you can continue on that. So how is it working well? The same as with monitoring. How do you know that your process is working? I'm kind of rushing through, but you get the picture as the similarities go. Can you relate which people support which component? So you kind of cross now a quadrant to make relationships. Who gets the alerts if something fails? And then again, which end user support services do you offer? It might be a chat, it might be a help desk, ticketing creation, so you know how they come into the process, and then which group will actually fix the production, and kind of get that kind of cycle going within the quadrant of production. So you make all these relationships between the different parts, and then I make the assumption, if you want to fix something in production, we go through the development process. Okay, I know that in a lot of companies, people just rush in still on the production system, but this is an assumption I make because I want to force them into the next quadrant, which is the project mode. It's not the production, it's the project mode. Again, we do the mapping just on that side. So if you want to have something fixed from the production, who are we going to ask at the people or the process side? Continue, external dependencies, support group, and make that relationship. And then we have kind of the whole mapping between the components. So usually what I see from people, they think of continuous delivery It's a lot about just the upper left quadrant, and the other quadrants aren't discussed that much. So it gives you conversational starter, you get that system up the board. And this is what I call seeing the DevOps system. It's not everything in your company, but that exercise, what I see, helps people to kind of see and get the conversation starting. So who finds that interesting or would try it when they get back? A few people. If you do try, get me some pictures. That's always nice to learn from others. I've seen the exercise also done within meetups that you just say to one person, you pick your architectures, and the other people start asking questions, and then they can learn how people kind of go through these different phases. It's a common ground. It's the first conversational starter that has mapped the system, gives you an overview. So there's a few observations when people do this kind of exercise. The first thing is, when I merely ask, draw me your production components, and some people from that first question will immediately draw their CI pipeline because they consider it production. So it gives you a kind of sense of the maturity that people think of the production is completely something separate, or it's already the whole picture in the upper quadrant to go from the dev to the production. The other thing is that you will see that the number of components they draw in the production will equal the components in the dev. So it resembles much closer in both the environments, the more mature kind of people are working in that. And I told you before, if you come in an environment where there's all the question marks about end user requirements, you know, like, okay, this is so focused maybe on the ops components only, and they don't have any clear view on the business. The devs might have it because they're closer related. They might have a view kind of what the end user is using because they get all the tickets of the things not working, but they don't really know what is important or how it works together. And then the more mature I see is that they also care about all the external dependencies. They bring that immediately into the discussion. So we kind of seeing the system, and now the next part is to focus on the flow. So it's a kind of that kind of feedback going and making that flow faster. And it's actually looking at points of friction. Where can I accelerate, or where can I make the process so there is not that much overlap? So it's finding the bottleneck in your system. And that's the next part. You have that mapping in the board, and then you say, okay, you can look at your backlog, kind of discussions points, your ticketing system, and kind of see the global areas. It might be in the delivery, then maybe that's important that you kind of work on your deployment, but it might be somewhere else that you don't know how to support, or you don't have a standard way of getting feedback into your project, so you don't know what performance or you're running in or all that. Another way of looking at it is that the upper quadrant is your technical debt and the lower part is your social debt. It could be for various reasons. Historically, you're coming into a company that they always work like this. They had like issues. They separated people. It's a way of looking at it. So we're seeing the system, and we're kind of found a few of the friction points that we want to at first improve. And I see there's globally 4 areas of improvement. The first kind of area is where you extend the delivery to production. It's the whole continuous delivery. It's kind of going faster, moving things faster to production. The other area that I see is that you extend the operations feedback to the project. It's kind of the loop back, monitoring metrics, as we will see. will make that more interesting. It's kind of a part that I miss in the continuous delivery book. They kind of talk about it, but you really have to read between the lines. It's all about, okay, we'll build the software, we'll package it, we'll ship it faster, but if you ship it faster, you don't learn. That's kind of hard to kind of improve yourself. So these are the typical initial kind of touch and go points between dev and ops in a project. There is a cycle around it, which is embedding the project knowledge into the operations. So it's not just shipping the product faster, it's shipping the product faster, making sure that the people who have to run the product understand it better, and they're like, know everything the project is doing, so they're not waiting until something pops in production and then they say, oh, we didn't know that was going to happen. So that's kind of a more elaborate cycle around it than just optimizing, making that delivery point touch and go. And the reverse is true, that you embed the operation knowledge immediately in a project. It's put things on your backlog so you can actually prioritize improvements that need to be done in operations. If you always keep discussing, we can put up some metrics, but nobody actually uses them, then what's the point? The point is that you get it on the priority list if it's important enough that people start improving it, or that they take it into account when they're building their new product. It's not an ideal world on the right. It might be on the left, but it's certainly not on the right. In these areas, I tend to think 3 layers. You've pointed out the tools, or kind of the technology, the process, the people interacting, and then there's the culture, because you can have like the most fantastic process. If nobody wants to follow it, they will not. So will you actually follow the process? And then you can go on and say, well, within each area, there's a maturity level. How many people have seen CMMI levels before? A few. So starting as something unpredictable, just ad hoc, kind of going to the completely, we're there, but we're just like fine-tuning the levels of the optimization. You will see that in each of these areas. And the funny thing is that a lot of companies go to DevOps and they think it's the deployment, so area 1, and they go from initial to optimizing in area 1, and they totally neglect all the other areas. I tend to think of it as this kind of tub full of water where you have the sides, in wood. If there's one low, the water will leak out at that level. You can optimize and build the highest wall on the other side. It doesn't really matter. This exercise actually has also been done for the continuous integration model, where they kind of describe, it's easy to use source control. It used to be insane to do continuous deployment to prod. For a lot of people, it's still insane. So there's definitely like a build-up. I don't think you can ever go from intro to insane on day 1. And this is a kind of visualizing it in kind of like these index cards. The name of the thing you do, where do you interact on which layer, the level you do, which area you produce. So I'm hoping to kind of describe a lot of the practices in this kind of model. So you look at your system, you say, hey, we're hitting some area problem here, and then you'll kind of have a catalog of practices you have that other people have tried. It might not work in your context, but at least you get more of options that you can try in your environment. And to me, this is kind of the reason why DevOps is this multi-layer thing, because depending on where your bottleneck is, you'll be doing something else. And this is a set of practices that you see. It could be monitoring, could be in production, could be like a people hack you're doing. So I think this might be the closest you get to the DevOps manifesto. It's the elephant in the room. Does everybody think something different? Okay. We're seeing the system. We kind of have a way to map which areas that we can improve. Now we can look at some of the practices people have been doing. So who has done some Puppet and Chef stuff or config management? A few. So initially, it kind of starts as the automation tool. But what you see, the power of the devs and the ops people using the same technology or the same words. Oh, now we have version control. We write tests for our Chef code. It's a great conversational starter for people to, instead of living in two worlds, they now have a nice discussion point that kind of builds up a discussion again. It's also a nice way of having executable documentation. So that really helps in embedding operational knowledge into the project. You know, oh, you need these packages with that tuning. Okay, I can just look at the code. It's there. And we know I can just run it to see if it's okay. It's not that big wiki that nobody wants to update. And if you do all the 50 steps, you kind of say, oh, well, that's outdated. And it's a common language. Might not this be the common language between dev and ops here? It's a common language with people outside your company. Now you can share the way you install a Drupal site or a Tomcat. In the past, people were writing their own scripts in their own set, but they couldn't share it outside because everybody was using a different way, different names of functions and so on. But this is something infrastructure as code, as the additional merit of just automating things, has brought into the world. So now we, instead of just the code we're sharing, we can share our modules outside to the world, and people start reusing that. There's another tool that kind of ties into it very well. So remark that I now kind of talked about the technology, but it's the way you use the technology that will make the difference here. If you're just using Puppet and Chef, and you're only doing it on your machine, and you're not sharing the code, and nobody's working on it together, you can hardly call it DevOps, because the only thing you did was automate it for yourself. You stayed in your own silo. You haven't really started a conversation, and it didn't get that same benefit. The same thing is with Vagrant, which is a way that if you have the infrastructure as code, I can now create very easily virtual machines on my laptop that will recreate the production environment. So if you're developing on a Mac and production is on Ubuntu or CentOS or whatever, I can use the infrastructure as code, put the virtual machine into a state on my laptop, which is the same as production. So it's very powerful in that I can reproduce the environment. You will be able to also create it very disposable. If it doesn't work and if it pollutes your laptop, because that's one of the dangers of setting everything up on your own laptop, is that it becomes developer friendly. You've opened all the permissions, very nice. You give it all the packages that it needed because it was already there. So this is one of the things that you will be able to reuse, but also retest whether you got every dependency right that you want to put into production. And because it's code on the repo and you're used to your Git, you kind of understand the tests, you can now do your changes yourself as a developer. I really recommend when you write your first infrastructure as code, just pair together with your ops person and write the Puppet code or the Chef code so you understand it and you can keep on enhancing. You don't have to wait for that ops guide to change the code. It's really this, almost the self-servicing creation that we're now a shared owner of the same base, and it's not because you entered the dev silo or the ops silo that you're entitled to do the changes. It's now much more open. So you can actually the reverse is true as well. If you change something in production, if you want that to be used on the dev side, you just change the repo. In the morning, the devs come in and say, well, rebuild me the machine for the state as it is now in production, and you get the state. So it's the reverse is as well true. It's only a couple of minutes it takes to spin up the whole VM. I was working on a cloud environment in Atlassian, and I had the whole cloud environment on my laptop, 7 different machines running, and I could prove that we would be never able to reinstall the whole cloud because a lot of the dependencies had changed. Just by being able to do that exercise, it was very powerful. Okay, so we kind of got a lot of area 1, but you can see that the other areas do get extra as well, just by using a tool differently or the way you share it. The same thing is true with monitoring and metrics. The obvious one is the devs can see the production usage or what of the problems. How many people are able to look into the monitoring system of their ops group? Only a few. The others, would you be interested in looking at it? Yeah? So this is one of the things that the ops people need to work on is the devs typically move to the cloud because they're fed up with the ops people saying no for certain reasons. And they like the self-servicing from an Amazon. If I want a machine, I have it now. If I want this, I get it now. So I usually advise them to work in the same way. Make your same setup, even if it's not the cloud, but if it's internally, make it self-servicing. It's more of a pull system. It becomes like, I want this, then like we're pushing a change to you. No, you can get it. Test it. We give you all the tools. Isn't that great as an ops group? You can just say, well, now you're responsible for everything. And if you care within your code of a certain metric, which is the number of logins, or maybe something else you're tracking, you're able to add a metric without even asking to the ops folks. Just add it in your code, and once it's deployed in production, you see that metric started using, and you have your information. Is it being used? Is it performant? You can watch all these things, and you can just add it. So StatsD makes it very easy to just integrate a library in your code, have it write out the stats, and then they become visible on one of those big screens that you want to have. It's really powerful. Everybody has their own namespace, and you can just work in that. And the nice thing is, how many arguments I've seen people saying, well, I think it's going to be slower. Yes, but we should do this. Would it be great to have some non-subjective material with your graphs that you can say, well, you know, it was important, but it only happened once during this time, giving these constraints, so it's not important. Or this is the way an ops person can prove, you know, you've written great code, but we've seen the performance go slow. And there's no argument. Did it happen? Did it not happen? No, I have a graph to show you that it happened. We should do something about it. Another practice is developers wearing pagers. Who's doing that currently? Who's looking forward to doing that? It's a hard one, but I can guarantee you if you do that, you will start to care about the production. I think the flip side is you will see all the things that nobody told you to optimize or to make your code ready for. It's not the product owner that will tell you that it has to be performant or it's going to be there. These are the things that if you take them into account earlier, that you will learn. The flip side is true as well. If you're in the operation group and you take a ticket, you will bring know-how to the ops people who don't know the application level or the business logic. You can bring that into the team as well, because they're not used to it. They didn't have the conversations. They weren't there in the sprint meetings. They don't know. But you can bring that into the same team. Usually the developer wearing pages is when you do a launch, you're responsible for X time, and then you move on to the next. So I usually make the reference, you created a baby, you care about the baby. That's when you start like still being important and wake up at night. After a certain time, you say, well, now it can run on their own. There's actually another part, like when it grows old and ugly, you have to start caring again. But we're still out there. And you'll, once you started fixing these things, you'll say, well, you know what? I can write a test to prevent this, that it doesn't get in production. It's one of the nice things if you're a dev, you're able to do that because you can code, you have very easy access to the test, you have the knowledge to create that test, and once you put it in, it's there. This is the secret why companies are saying, well, we can do so many deploys a day. Tests are your brakes. If it fails, you know, it doesn't get to production. It's writing code tests is important. It's not about, I can go fast to production like a puss, but it will always fail. No, that's not what it's about. It's creating that confidence. Chaos Monkey, I guess, has been talked about at this conference. Creating the problems earlier and knowing these problems as they will occur earlier. It's hard to see, but this is a tool that Atlassian used internally. It started as one of those ship it or FedEx days. It's visualizing the errors per group, per team, or product. And the fact that just by making that visible, it kind of got attention. So let me tell you about the previous strategy we had. There's a core dump, we mail the developer. What did I do? We create a mail filter that just puts it to trash because there's nobody else will see it if we don't handle it. Here it's like plain in the face. It's not getting better. It keeps on red, or it's improving, or something happened. I do want to point out that it's not about like pointing fingers. It's kind of externalizing that things happened, which is the important part. Chat ops. Who has heard about chat ops before? A few people. Who's using an internal IRC or chat room for between developers? Yeah. So this is mainly like hooking in the ops people as well, getting the notifications from production when things go down, and even with a system like you bought, if you want to do a deploy, you just type in the chat, deploy, server, code, any tag, it goes off. So the importance of this, it's a shared view that you create by that chat, and also a history that you can relate to. Oh, on this side, the alert goes off, two people say they're looking at something, then somebody else has joined. It's a nice way of tracking the history if you want to learn from new events. And it's really helpful in the postmortems. This is not the fuzzy thing that, you know, it kind of happened, and when did somebody do something in the system? No, everything happened in that chat. Whether it's the system that did something, the devs did something, or the ops, the conversation is held there. And then if you relate it back to any of the metrics in the monitoring you took, you can kind of say, well, he changed his parameter. Oh yeah, it's a line on the graph, like an event, and we see the graph now go like this. So you can very easily relate now events, not just on the monitoring side, but on the people who are interacting side. I did a new deployment here, and I see my performance go like that. It's a very nice way of relating these things. And then more and more companies are publicizing the postmortems, kind of like the retrospectives, outside. A system failed, they just put it out on their blog with all, you know, all the details like, hey, we did this at that time, then it was important. It's actually the best indicator if a company starts doing that. Even though they failed and they massively screwed up, it's just showing that they care and they're on the problem. You will fail. There's no way you will not fail. But the fact that you can see that a company like that has a reaction, a structured way of tackling these things, that gives me more kind of a faith for them supporting my external service now. Game days. I think one of the game days that was done for the Obama campaign, they would just before the actual peak of the campaign, kind of like Chaos Monkey, but somebody who has like a script in his head, and you will go to the data center and pull cables and see if it survives or do a different thing. Just the mere threat of that it's going to happen, and you should always follow up on the threat, because once they know you're not following up, it's like a dangerous thing. But just that, and then get people in the room and say, well, you know what? If I pull this cable, what's going to happen? You'll find your bottleneck like nothing, I can assure you. And again, if you get different people in the room, they will find you and give you the feedback on different bottlenecks. It's not the one architect that knows every problem. It's the different people that will know, well, you know, kind of, I had in my code this / fix me. You know, we really need to fix it now if you're going to do that. And setups is kind of a mixture of both. It's an application that the people from Rails machine developed, and it's in a virtual machine, and people can set it up on their laptop. It reproduces the most often occurring failures in production, and people can just play around with it. So memory leaks, I don't know what, full database, disk full. They just have a way to set up this scenario, and then they train the people who go into ops with this. It's an easy way. Like, we know this is going to happen, so we might as well train you instead of just like you're on call and you're the first thing you do is like, how do I do this? No, you've like practiced this like 50 times how to get around it with documentation of people who already did it. So it's a great way of learning. It's not just finding the bottleneck. This is especially sharing those operational knowledge back into your project. I guess the simplest or the most known thing is just Amazon saying, you build it, you run it. Or it's very simple. And this is what you'll end up with. There's going to be less of a dev, less of an ops. You're all doing different things, and not always overlapping, but it's going to be like more and more an overlap. And you can kind of start discussing whether it's going to be all dev, but that's another story. So we got it, we found the bottleneck, we see the system, find a bottleneck, showed you a few practices of people kind of tackling different areas, and then you find the feedback loops. Kind of the things that I do this, I improve it, but now something here happens. It's often very hard to distinguish between the symptoms and the real cause, so you might have to go through a few iterations to kind of actually tackle the real cause, or people will not tell that immediately. And I can guarantee you that your bottleneck will move. Because if you fix something here, it's a system, and if you change something in the system, other things will happen. So again, don't keep optimizing the same part, because it's useless. The other things will kind of have a new dynamic in the system, and you have to tackle those as well. And you might even ask yourself, companies ask me, go in, do some DevOps thing. The first question, usually in the beginning, was more, okay, we can do this delivery automation. And now more often than not, I go in and it's like, are you sure your bottleneck is there? Maybe it's in HR because they don't pay enough salary, or finance who blocks all the requests for new servers. So be aware that it is part of a bigger ecosystem, and we started out with dev their own silo and ops their own silo. We put them together, and now we're in this whole ecosystem. And you can even take it beyond your company. Maybe it's the market. And you kind of seeing the system never stops. But be aware that it's very hard to do something about the bottleneck that's beyond your control. Once you get there, try to be friends to the other parts. It's again the same story. And Michael has said it before, it needs context. Whatever somebody comes in and says, well, I have this great tool, or we've done it at Facebook like this, it can have merit, but if they don't know the context and they don't know your system, they might just be some optimizing the one thing that you already got right, but you're like optimizing and fine-tuning, and they should be spending their time on somewhere else. So DevOps is, I think Oscar Wilde phrased it well, it's a dangerous, an idea that is not dangerous is unworthy of being called an idea at all. So the same thing will happen with DevOps. As Michael described, the hype cycle can be very dangerous for people just trying things and not getting the thing right. So if there's one thing I hope you got from this kind of meta describing with some practical examples, that it's not about the tools, that when you see the system, you kind of have a better chance than doing ad hoc practices that you don't know where this is supposed to fit in. And everybody should care about the whole system. Part 4, to be continued. So I guess I'm kind of out of time. These are places to look for. There's the Devops Days conference that I run. There are other great podcasts. There's the Devops Weekly, Monitorama conference. And there isn't really a DevOps book. We're working on a DevOps cookbook. But these are different books that address already parts that are useful. So my slide's going to be up, so if you want to read that. Especially explaining to your C-level management, just buy them a bunch of the Phoenix projects. It's a narrative. It's actually the IT version of the goal of Elliot Goldratt. And it usually strikes like a nerve with them to get things going. And this is it.